All right, good morning. And today we're going to be working on definite integration. And for the past 2 weeks, we're working on indefinite integrals. And to work on the indefinite integrals, you need to make sure that you know your antiderivative rules, your basic antiderivative rules. So we've learned two antiderivative rules so far, the regular power rule of integration, and we also did U substitution last week. And today we're going to be seeing a different type of integration because now our integral symbol or notation will change a little bit. And while you were waiting, I asked you to find f of u, which is the original function, because we know if we do the indefinite integral, we're basically finding the original function of our f of x. Now we have the derivative function, f prime of u, and I want you to find f of u given that f prime of u is u squared plus square root of u all over u, and f of 1 is equal to 3, which means your constant is no longer just going to be on its general form. There is a value of a constant that you need to be able to find. So since you've got time answering this, can you please type in the constant that you found from this problem? Let's see if you did it right. So go to the chat box and just type in the constant. Let's see if your answer. Maybe you're still working on it, and I'll try to work on this as well. So if we're looking for f prime of u, so the given function is f prime of u equal to u squared plus u to the 1/2 times u to the -1. So by using your law of exponent, f prime of u. So basically you're doing a lot of algebra here before you reach to calculus. So you'll have u to the 2 minus 1 plus u to the 1/2 minus 2 all over 2. And it's still algebra because we're just evaluating this so we can use our power rule or the power rule version of the integration. So you have u to the 1 plus u to the 1/2 minus 2 all over 2. It's -1/2, right? And this is now our f prime of u. So no calculus yet. It's still algebra because we're still just using the law of exponent. So now that we have our modified version of our f prime of u, now we can use our integration or the power rule process. All right, let's do that. So f of u is equal to the integral of u to the 1 plus the integral of u to the -1/2 plus the constant c, right? So we just need to evaluate this. So we'll have u to the 2 all over 2 plus u to the -1/2 plus 2 all over 2 all over, what's -1/2 plus 2 all over 2? 1/2, right? So our function for f of u is going to be 1/2 u squared plus 2 times u to the 1/2. Is it positive 1/2 or negative 1/2?
I got 3/2 for my constant.
You got 3 over 2 for your constant?
Yeah, negative.
-3/2? Well, we'll see. Let's see if that's going to be -1/2. So this is going to, -3/2. So what is my exponent here? -1/2 plus 3 over 2 is?
1/2.
Okay. Plus c. So f of u is equal to 1/2 u squared plus 2u square root plus c, right? That is our f of u, but we know that f of 1 is equal to 3, so we're going to apply that to our functions.
Oh, well, I put f of, my bad, I'm wrong. Excuse me, I'm trying to work and do this at the same time, but I am wrong.
You're trying to what? Where are you at right now? Let's continue. 1/2, 1 squared plus 2 square root of 1 plus c, right? This is our equation. If we use f of 1 is equal to 3, but we know that f of 1 is equal to 3. So we're going to change that into 3. So now we have, let's put it up here. 3 equals 1/2 times 1 plus 2 times 1 plus c. So I have 3 equals 1/2 plus 2 plus c, which is 3 equal to 2 and 1/2, because 1/2 and 2 is 2.5. But since we want to use improper fraction, so we have 3 equals 2 times 2 is 4. 4 plus 1 is 5. 5 over 2 plus c. And we have 3 minus 5 all over 2 plus, equal to c. Same denominator. So these are all algebra work. So we'll just change this into 2 and 2 so that they have the same denominator. So c is equal to 6 all over 2 minus 5 all over 2. And what is 6 all over 2 minus 5 all over 2? 1/2. So again, just like what we've been doing in calculus, I am confident that you can do your calculus work easily and accurately. It's just the algebra that can be a little bit of a pain when we're working with problems like this, because 1/3 of the work is calculus, 2/3 of the work in this problem is algebra. And now to complete our work, we just need to plug in 1/2 to f of u. So our f of u is this function. So f of u is equal to 1/2 plus u squared plus 2 squared of u plus 1/2. And we found f of u. So for today, we're not going to be doing a lot of this for today because we're going to be working on definite integration. And definite integration, this is indefinite integration because there's no defined limit, but now we're going to be working on indefinite limit or function. So the first thing that you need to do is to know your new notation. So this is the new notation that we're going to be using today. A to b of f of x dx. This is definite integral. And the reason why it's definite integral, because you have a defined lower limit and defined upper limit. Now, the only thing that you need to do is to be able to evaluate it. And how do you evaluate your definite integration? Simple. We're going to have our example in finding the integral of this function. Let's have the first problem for today on definite integration, and we'll keep it simple. The first example is to find the integral of x, which is a derivative function from 0 up until 1. All right, so this is our integral function, derivative or antiderivative of x dx from 0 to 1. Now, to evaluate definite integral, all you need to do is to get the integral of x dx. And the integral of x dx is, what is the integral of x dx? X squared all over 2, right? And once you have found your integral for your function, which is basically now you are using the original function, you're going to evaluate it from 1 or from 0 up until 1. So there's no constant c in your definite integration. So that's one of the major differences between indefinite integral and definite integral. Indefinite integral, like this, there's no constant. Indefinite, you need to find the constant c. So how do you evaluate this now? We're just going to evaluate it using substitution. So we're going to have x squared all over 2 minus x squared all over 2, and you're going to evaluate the value of x with 1 and with 0. So that's basically how you evaluate your upper and lower limit in the antiderivative or in the definite integration. So by using a little bit of algebra, you will have 1 squared all over 2 minus 0 squared all over 2. And what is 1 squared all over 2? It's 1/2 minus 0, which is equal to 1/2. So in working with definite integration, what you're finding is the area under the curve of your function x dx from 0 to 1. That's basically what you're looking for this function. So to make it more verbal and more visual for all of you, whenever you're looking for function like this, you're basically finding the area under the given function from 0 up until 1 inclusive. So this is basically what you're looking for. And to give you a better visual of that 1/2 that we found, because as I mentioned in calculus, you cannot just be learning steps and procedure or process. You need to make sure that you're understanding why you're getting this value. Now, if I'm going to graph the function x, and the function x is basically f of x is equal to x, or y is equal to x. And f of x equal to y equal to x is equal to a linear function, right? And it's a linear function that is a diagonal line passing through 0 with a slope of 1. Boom, boom. This is your function y equal to x. And you are finding the area of y equal to x between 0 and 1. So this is 0 and that is 1. And this is the range of values. That's why it's called limit. It's basically your lower and your upper interval that is included in your function. And now we have an illustration of your function y equal to x. And you need to find the integral of that function from 0 up until 1. And what did we get? We got 1/2. And that 1/2 is basically your area under the curve in reference to square units. And this one, we have 1 unit. This is 1 unit, 1 by 1. If we draw a line right here, we know that this is 1 square unit, but we got 1/2 because we only need, the function that we're using or working on is a diagonal line. So that's why we're using this mathematical process to complete or find the area under the curve of a given function. I hope you're understanding now why we have this crazy process right here. So Alyssa says 2, Eternity says 2, Rebecca says 2. So now you have 2 units squared or 2 square units of your area under the curve. And let's see. The integral of x dx is obviously 1/2 x squared, and you're going to evaluate it from 0 up until 2. So it's just pretty much the same as this. So we'll have 1/2 x squared evaluated from 0 up until 2. So you have 1/2 times 2 squared minus 0. So you have 1/2 times 4. And what is half of 4? 2 square units. And that makes sense because if we're going to look at this and extend our line right here, 0 up until 2. And now the range of values that we're working on increased to 0 to 2 instead of 0 to 1. And notice that we now have this area and this little area right here. And what do we have? 1, 2. 2 square units of our area under the curve. So that is why whenever you're working with integration, make sure that you're understanding why you're doing the process or the syntax on how we complete this work, because we're going to be doing a lot of this later on. And then I wanted to work on this. Let's change the function now. I think you got the point. Example number 3. I want you to find the integral of the function x plus 2 dx evaluated from 0 up until 3. Okay. Well, we'll see. Okay, so since some of you already have their answer, u squared. So unit of measurement in calculus is important as well. So make sure you know your unit of measurement. So it's unit squared because we're looking for the area. So let's do this. The integral of x plus 2 is going to be x squared all over 2 plus 2x evaluated from 0 up until 3. So that is their integral function, right? And this integral function will be evaluated from 0 up until 3. So you have 1/2 x squared plus 2x minus 1/2 x squared plus 2x evaluated from 0 up until 3. Are you still seeing it? Okay. So now by substitution, we have 1/2 of 3 squared plus 2 times 3 minus, and we know that if we plug 0 here and here, it's just going to turn into 0. So you just need to worry about this. So we have 1/2 of 9 plus 6, which is 9 all over 2 plus 6. And what is 9/2? 9 over 2 plus 6? Is it 21 over 2? A. Yes or no? Yes. 21 all over 2. Okay, what is 21 all over 2 in decimal form so that we'll have a better visual of what 21 over 2 is? You don't need the calculator for this. What's half of 21? 10.5. 10.5 units squared. Now let's see if 10.5 units squared is an answer that makes sense. So the function that we're working on is a line x plus 2, which means 1, 2. The y-intercept is at 2 that has a slope of 1. And I mean, the y-intercept is 0 with a slope of 1. I mean, 2, 0. That is our line. And we evaluated from 0 to 3. 0, 1, 2, 3. Let's extend it. All right. So this is 1 unit. This is 2 unit. So let's say this is the 3rd unit right here. And we have this. We are just approximating. If we're using a graph paper, maybe it'll be a little bit more accurate. But since we're just sketching it, 10.5. 1, 2, 3, 4, 5, 6, 7, 8. 0.5, 0.5, and a little bit of that, right? So that is how we compute for the definite integration using the formula. And that's all you need to know when you're working with definite integration. You need to know the process, which is find the antiderivative of the function and evaluating it from the lower limit to the upper limit, and evaluating it from lower to upper means you're going to subtract or find the difference between the upper limit and the lower limit. Now, since we're working on a math process, which is pretty much going to be the same for any function, you need to know your properties. And properties is obviously rules in integration to understand integration better and to have a little bit of shortcut in your head. So properties, just like law of exponents, if you know your law of exponents really well, then you don't need to do a lot of work. Same with definite integral. The first property is that the integral of your f of x dx evaluated from a up until a, which means you have the same lower limit and the same upper limit, your value is going to be 0. So remember that. So if your lower limit and your upper limit are the same, the answer to your integration is 0, because obviously if you subtract 2 and 2, it's just going to be 0, right? The next one is the integral of your function f of x dx for any function evaluated from b all over a. And notice that our lower limit is bigger than the upper limit. When this happens, you need to evaluate it from a to b of f of x dx And basically, you're just going to negate your answer because we're looking or working on the area under the curve. So if we're working on an upper and the lower limit that is not in order, you need to make sure that it's going to be in sequence form. All right. 3. If we have a function like this, integral of f of x dx, and we have an annoying constant k between a through b, we can ignore the constant and evaluate our function so that we can concentrate on a smaller function to evaluate, because we know that if there's so many constants that you're seeing in your integral function, you're bound to make mistake or you're prone to error. So to avoid that, ignore it a little bit and just plug it into your final answer. So let's say you have evaluated your definite integration, you have your u squared or function u to the 2, just multiply with the constant and that's your answer. And if I have integral from a through b of f of x dx plus integral from b to c of f of x dx, your function for this integral will be your f of x dx from a up until c. So notice that the upper and the lower limit, if that happens when you're adding them, then you can perform this particular property or rule of integration. All right, so these are some of the properties that you should remember so that when we see problems like this, it will be a lot easier. Now, let's perform this type of integration. Let's have f of x is equal to an absolute value function. And our absolute value function is given by 2x minus 1. So we're going to be evaluating a function f of x with 2x minus 1. And we're going to find its area in between 0 and 2. So that is our limit. And we're going to find its area using integration. So the first thing that you need to do is to rewrite this function into definite integration. And the definite integral of this function will be the integral of the absolute value of 2x minus 1 dx, because this is the derivative function between 0 and 2. So this is what you're going to be evaluating. Now we know that you need to visualize the function that you're working on to be able to find the area under the curve. Do you still remember what the graph of absolute value of 2x minus 1 looked like? What is the shape that the absolute value of 2x minus 1 will give you? Can you please type it in? Oh, Rebecca is quick. It's a V-shaped graph, and that is correct. It's a V-shaped graph. So it's not like a linear function that we have just a straight line right here. Now it's a V-shaped graph. So let's graph it first. But how are we going to graph that function? You need to know your solution so that you would know the point of intersection of your graph to the x-axis. And to find the solution, equate it to 0. So the solution is going to be 2x minus 1 equal to 0. 2x is equal to 1. And x is equal to 1/2. So that is the solution of your absolute value function. And why is this important? Because it will help us visualize the function that we're working on. So this is 0, this is 1, this is 2, this is 3. You're not seeing it. Okay. So since we have a solution of 1/2, that means the point of intersection of our V-shaped graph is at 1/2. There. So that's our vertex. And we know that it's a V-shaped graph. And this is the graph that we're working on. And we're evaluating the integral or the graph or the area of the curve between 0 and 1. So this is 0 and 2. And this is 2. So this is our boundary. And our boundary gives us this. Boom, boom, boom. And boom, boom, boom. Okay. So how are we going to find the integral function or the area under the curve of our absolute value function from 0 up until 2? We're going to be dividing our function into two functions because we know that an absolute value functions, no matter what your value is, it's either positive or negative, your value will still be negative, right? So we have two partitions to the left, to the right and to the left of the function. And to the right of the function, this is whenever your value of y or the value of x is negative, it will still give you a positive value of x. So that means this function represents 2x minus 1, and it represents the negative value. And from here up until here, from our solution, this will be 2x minus 1, and this will be the positive value of your x. So basically, you have two functions that you're going to be integrating. So you have the area 1, and you have the area 2. So now you're computing for the two area of a function. Now the question is, how are you going to write your function using calculus? Try it out. What will be your integral function now that you are seeing this type of function? So that means we have two areas. That means we have two different integrals. So for area 1, and area 2, it will represent the function negative 2x minus 1, which is negative 2x plus 1 dx. And that area is evaluated from 0 up until 1/2. There. And you are going to add it to the area of this bigger triangle. And that bigger triangle is going to be the function of our positive function 2x minus 1, evaluated from your lower and upper limit will be changed, obviously, because now you're evaluating it from 1/2 up until 2. So that means you're going to be figuring that out. Okay, now that I set up my function, can you please find your integral for the little triangle and for the bigger triangle? So this will turn into negative 2x squared all over 2 plus x evaluated from 0 to 1/2. And this is going to change into 2x squared all over 2 minus x evaluated from 1/2 up until 2. So if I'm going to simplify this, this is going to be negative x squared plus x evaluated from 0 to 1/2 plus x squared minus x evaluated from 1/2 up until 2. All right, I'm gonna show you my work. Stop share, because I'm going to share you my screen, because this is our integration. So we have the function, the absolute value 2x minus 1. The first step that you need to do is to find its solution, and its intercept is 1/2. And you have the negative side and the positive side of your absolute value, which means it's still going to be positive even though you have a negative values of x or the positive values of x. And that's basically why you have the absolute value in the integral function. So now that we know that the solution is 1/2, we have the graph of our function, which is a V-shaped graph that has an intersection at x equal to 1/2. The positive side and the negative side are divided. To the left of your solution is your negative 2x minus 1. And to the right of your solution is your positive 2x minus 1. And now you're going to create your integral function 2, because you're seeing two triangles of different shapes. So that means you need to separate your integration. So the first integral is evaluated from 0 to 1/2, but the function that you're using is the negative function, which is negative 2x minus 1 or negative 2x plus 1. And the other function, you're going to add it to the bigger triangle, which is an integral function from 1/2 to 2. and using your calculus, you know that the function or the integral function is negative x squared plus x on the smaller triangle. And for the bigger triangle, it's going to be negative x squared plus x. Is it negative x squared plus x? No, it's supposed to be positive. And your answer should be 5/2 or 2.5. All right, so the 2.5. Now, do you have a graphing calculator? If you have a graphing calculator, I'm gonna teach you how to use your graphing calculator to compute for the definite integral. This is why TI-84 is good at this. So using your TI-84, you can find the definite integral. I got that, but I didn't want to be wrong. So Rebecca got the answer. Now, for those of you who got 2 or 1.5 or -3, or I don't know what answer it is, the answer should be 2.5, and that will be your homework for tonight. Redo your work, and your goal is to get 2.5 in your answer, okay? I'm not going to rework this anymore, but I'm going to show you how to use your calculator to do this. All right, so to use your calculator to produce definite integration, you use math, and it gives you an array of function in your calculus work, and we're not going to do derivative. We're going to be using integration, and it's function 9. So this is a visual representation of your integral, and the integral function is an absolute value from 0 up until 2. So we're going to plug this into your calculator. So 0 up until 2. The only thing that we need to worry about is the function, because that function is an absolute value, and we know that 2x minus 1 is different from the absolute value of 2x minus 1. So how do you find the absolute value in your calculator? Go to math, go to numbers, the first one. Something that we don't have right now because of quarantine. All of us are getting really, really fat. No exercise for no abs for us. So this is your abs, and it's going to be the abs of 2x minus 1, evaluated from 0 up until 2. Make sure to push the x or dx, and this is your 2.5 or 2.5. And we know that if we have this function, 1, 2, and 1/2. 1, 2, see? 2.5. So that is why you need to make sure that you are understanding the concept of calculus visually, and you're understanding how the algebraic or analytic work is done using this method and technology. You also need to know your technology and know how to use your technology. If you don't have a graphing calculator, you know what? There's so many apps online. I'll show you, because calculus, this is not, I'm not trying to teach you how to cheat. I'm trying to teach you to be resourceful, because you need to understand how to work on problems more efficiently, right? So what I do whenever I'm working with problems like this is I go to Google. And how do you use Google to be able to do some calculus work? Not to cheat, but to verify if your answer is correct. Okay, I'll just use the desktop since I cannot find yours. So let's say integral, definite integral calculator. So you can use Google to figure it out. Definite integral calculator. I usually use Wolfram Alpha. So this one. So integrate x, the function a while ago, from x is equal to 0 to 1. We know that our value is was 1/2 a while ago. And it's giving you your function, it's giving you your graph, and it's giving you the answer. Look at that. You don't even need to use this. So if I give you homework tonight, well, of course I'm going to give you homework tonight. I'm not going to give you the answers this time. I'm going to let you use technology to verify your work. But again, of course, you're not going to be cheating. You're not just going to be too dependent with technology, because you need to have the skills first so that you will be able to understand why technology is working for you. Because in real life, let's say you become an engineer, you become a statistician, you become a mathematician, you become someone who's using calculus or statistics in real life application. You're not going to be using this to compute for measurements. You're going to be using technology, and to be able to do that and to be able to accurately use that, you need to be able to understand the rationale behind the calculation, just like what you're seeing in the screen right now. And that's basically one of the lessons that we are going to be doing today. Knowing your calculus, knowing why you're using this crazy formula right here, and how to use technology in calculating problems like this. And this is one way of doing it, right? Pretty neat. Math magic. So again, I'm not teaching you to cheat. I'm trying to teach you or showing you why it's important that you should know your math work first before you move on to using technology, because calculus, it's a marriage of the two skills, analytic skill and the skill of using technology to be able to work out problems similar to what we're doing, okay? So that's it for today. As much as I want to give you more examples, it's just gonna be a repeat of all those problems. And I know that you can do it now, unless you want me to. Oh, wait. Okay, please give me the answers to 1, 2, 3, and 4. You don't need to completely integrate it. Just use the property. And I'll show you my answer. The integral of 2x dx evaluated from 5 up until 5 is just 0, right? Because that's the property. And we know that if we evaluated it, it's going to be a constant equal to a constant with the same value. So it's just going to be 0. So for number 2, we have 0 up until 3 of 2x dx, same function, but you cannot integrate a function if your upper and lower limit are not in order. Your lower limit needs to always be smaller than your upper limit. So this will be the negative value of, this is supposed to be 3 and 0. All right, so 3 and 0. So this is going to be 0 up until 3, negative of 2x dx. So what you're going to do is you will evaluate this from 0 up until 3, and on your final answer, it's going to change its sign. So from positive, it will become negative, and negative will become to positive. And for number 3, you have 0, 1 of 2/3 cosine x dx. Using the constant property, it's just going to be 2/3 of the integral from 0 to 1 of cosine x dx. And this is going to be 2/3 of, what is the antiderivative of cosine x? Is it negative sign or positive sign? Type it in, because I don't know. Negative. So it's negative sine x minus or plus sine x. Evaluated from, so we have negative sine 1 plus sine 0.
Hey, just kidding, it's positive.
Are you sure?
Yeah,
Rebecca?
yeah.
So how is this going to change our answer? It's going to be 2/3. It's just a minor fix. Change the sign. Sine 1 minus sine 0. All right. Between sine 1 and sine 0, which one is a special angle? Sine 1 or sine 0? Yes, Avner explained it to you. By the way, Avner is our guest student for today. He's still in high school, by the way. So I just invited him to attend my college classes. The given is from 0 to 1, x dx plus x dx of 1 to 5. So before you evaluate this, simplify it using the property, because this is just 0 up until 5 of x dx, of the function x dx. That's all I want to, I want you to work out, because if you evaluated this and you evaluated that, and if you add them up, it's just going to be the same values as this. And if you don't want to believe me, let's use technology. All right, math 9, 0 to 1, wrong, 0 to 1 of x dx plus math 9, 1 to 5 of x dx, 12.5. But math 9, 0 to 5 x dx, obviously it needs to be equal to 12.5, right? Boom, 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 12.5. So that is why you need to know your properties, because you need to know shortcuts. Well, not really shortcuts, but you need to know a mathematical proof on why your answer is such as that. All right. So that is how you complete your work. So for today, recap, we've learned the properties of integration. We've learned how to perform definite integration. We've learned why we're doing such analytical work to be able to compute for the definite integration, which is basically the area under the curve of your function between the curve and the x-axis. Do a little bit of exercise so you're not gonna get too fat like me right now. And that's it. Thank you so much for coming, and see you all next time. Bye.